Hello everyone. Previously, we have seen how to solve 2D and 3D problems in ANSYS. However, we used 2D and 3D analysis type for a single part only. In this lab, we are going to expand our analysis to the assembly, and we will see how we can model an assembly in ANSYS Design Modular and solve that assembly for structural analysis. In this lab, you will learn about how we can model the assembly, and the assembly that we are going to model is the base stand, and I'll show you the dimensions and the details shortly. Then we will see how we can connect different parts of the assembly in ANSYS for analysis. And after that, we will use 3D analysis for finding the von Mises stress and safety factors and deformations in the base stand. And finally, there is an assignment. So here you can see this is a base stand assembly, and it consists of a base, a pin, and a holder. All of these parts, they are made of structural steel, and the boundary conditions include the bottom face of this base. They are fixed, and there is a force of 1 kilonewton which is applied at this holder. This holder is connected to the base through this pin. The dimensions of each part are mentioned here. So first of all, we will start by modeling the leg of the base, and then we will create this hub of the base, and finally we will create the sketch and the holder inside the design modular. So let's shift to design modular and see how we can model and solve this assembly for these boundary conditions. In the design modular, let's start by sketching the leg base. So this is a simple sketch which contains two radii of 40 millimeter and 50 millimeter, and the extrude is 5 millimeter on both sides. So I'll start by selecting the XY plane, changing the units to millimeter, going to sketch, and we can use the arc by center. So the center is this origin, and the arc starts from this point to somewhere here. Then there is another arc which is a bit bigger, like this, and these two arcs, they are connected by horizontal and a vertical line. So ANSYS automatically detected this. Now we need to dimension the arcs. 40 millimeter is the dimension of the inner arc, and 50 millimeter is the dimension of the outer arc. So this is 50 millimeter, 40 millimeter, and finally there is an offset of 8 millimeter from the vertical axis. So this is 8 millimeter. The sketch is fully defined, and I can extrude this sketch both symmetric by 5 millimeter and generate this. We'll see that we will have the leg of the base here. Okay, in order to create the two copies, we can go to this create and select the pattern feature. So we need to select circular pattern here. The geometry that I want to create a pattern of is this base, and the axis is this one. So we need 3 copies of so yes, we need 3 copies. Sorry, we need actually 2 copies which are evenly spaced like this. So here we have a 3 the uh, so here we have three legs of the base. Now the second sketch in order to complete this base is this hub of the base. So the hub of the base is 35 millimeter above the ground level. So what I'm going to do is create a plane, which is the ZX plane here. You see, this is the ZX plane, and I'm going to create another plane for the sketch. So by clicking on this new plane button, I can create another plane, which is, let's say, uh, I need to offset this plane in Z direction by 35 millimeter. So yes, so this is the local Z in which the plane will move. Just create on this generate. So the new plane is created, which is 35 millimeter from the base. The sketch is simple. I'm going to sketch two concentric circles on this one. One and two. So these are the concentric circles, and the dimension of the circles are 6 millimeter radius and 10 millimeter radius, and extrude is 35 millimeter. So, so the diameter will be 40 millimeter, 12 millimeter. Yes. So the diameter will be 20 millimeter and 12 millimeter. This will be 20 millimeter and 12 millimeter. And we need to extrude this sketch by 35 millimeter from the base. So I'll select the sketch, extrude this one by 35 millimeter from the base, and make sure that the operation is selected as add material, and we want to merge the topology of both of these features so we have a single part. So we this way we have created the base. The next option is to create the hole for the pin, and the hole exists at 60 millimeters from the bottom. So let's select the ZYZ plane, click on the sketch button, and after clicking on the sketch, we can move to draw the circle, which will be the hole, and the dimensions for the pin are 6 millimeter diameter. So the dimension will be 6 millimeter diameter, and this is located at 60 millimeter from the base. If I go to modeling, and in the modeling, yes, this is the sketch, and I need to cut the material now. So sketch 3, I need to cut the material in both directions, both symmetric through all, and generate this. So the cavity or the hole has been created for the pin. Now the next step is to create the pin. The dimensions of the pin are, so the length of the pin is 30 millimeter, actually 15 millimeter extruded on both sides. I'm going to select the pin again, the sketch again, and then click on the extrude button, and this time I will change the operation option from add material to add frozen so that I have a second part which is a pin in this assembly, and the dimensions are so 30 millimeter, so 15 millimeter each side. So when I press generate, you will see that a pin is created, and here we have two parts and two bodies. So first one, I'll just rename this to base. The second one is pin. So we have two parts. Now for the third part, this is the holder, and if we look at the dimensions of the holder, so this is 36 millimeter tall, 18 millimeter of which is in contact with the hub base. So we can simply create a sketch on this surface which is at the top, and create the hub. So I'll just go to sketch and create a circle which is right at the center, and it is tangent to the hole in the base. So we don't need to specify the dimensions here. I'll just extrude this new sketch by 18 millimeter in both sides and keeping it symmetric so that the total length will be uh, for total length will be 36 millimeter. However, you see that I'll need to change this to add frozen so that we have the third part, which is the hub, which is the holder. So after creating the holder, I can see that there is one feature which is missing, and that is the place for the pin inside the holder. So the holder is connected to the base through this pinhole, and if I hide the base and the pin, I can see that there is no hole in the holder, and I need to create that hole so that the assembly is completed. One of the issue here is we cannot work on parts that are frozen, that are added as frozen bodies like this pin and holder. So in order to add hole in this holder, there is a strategy and the advanced tool that I can use. So first you see that this is the base, and we have added the base as a material in this design modular, and these two bodies, they are added as frozen bodies. You can see based on the color in the design tree. First of all, if I change this extrude from add frozen to add material, you will see that this just disappears because it just became the part of the base and added as the material. So there is a simple strategy that I can use while modeling, and that is, first I just converted it back to the frozen body, and here we have the holder. What I'll do is, in this design tree under the tools, I can select the base, and after adding all the features that were required in the base, I can freeze this base at this spot. So if you go to the tools, you see this freeze option. And when I click on the freeze option, After selecting the base is now frozen and it has all the required features, so we don't need to worry about the modeling of the base. Now the next step is to unfreeze the holder here. So this is the holder and I want this to be unfrozen. And now this holder is added as the material. Finally, in order to make the hole inside this holder, we already have the sketch in YZ plane. I'll just click on this extrude button, select the sketch that I want, and then the operation is changed from add material to cut material in both directions through all, and the target body is only the holder, so we want this to work on the holder actually. So when I press the generate button, you will see that the hole is generated in this holder. Now we have three bodies and three parts, so I can just unhide these and everything is in place. So this is the part that was related to modeling of the assembly. Now I can shift to the analysis portion. I'll just close this design modular tab and open the model analysis. When the analysis tab is open, you can see that all of these three parts, they are under the geometry tree and you can assign individual materials to each part, base, pin and holder. You may have noticed this connections under the model that just appeared because of the assembly. So ANSYS has automatically detected some of the contacts and contact regions, and when I click on these contact regions, I can see that what are these contacts. So we need to look at these in detail. So when I click on this contact region 1, you see there are three windows here. This is the main window that we were working with, and here on the right side there are two windows. So the first is related to the target body view and the second is the contact body view. So this just shows that which two bodies are connected to each other. So here I can see the print of the pin and the base. So the contact body is this base and it is selected here automatically. Contact body is base and target body is pin. So the surface of the pin is in contact with the inside surface of the base. And what is the type of the contact? The type is bonded here. So the bonded contact means that these two bodies, they are just fixed with each other. And here we have five different types of contacts that we can use. The first one, as you see, is the bonded contact, and it means that the two surfaces, they are glued together, and it also allows the two bodies to be penetrated into each other without any issue. There is this no separation contact. This is similar to the bonded contact, however, it can only be applied between two surfaces, to 3D or 2D surfaces. These two, the bonded one and the no separation, they are linear contacts since there is no separation between the bodies. So ANSYS can solve the problem without any non-linearity and a lot of time. If I move to the frictionless support, as the name suggests, the two surfaces, they are in contact with each other. However, there is no frictional coefficient between them. So they are the two surfaces, they are considered as frictionless. This is a non-linear kind of support, as it also allows a small separation between two surfaces. Like it is possible that the two surfaces, they are not in contact initially, and when we apply the force, there exists a normal force, and those two surfaces, they start to be in contact with each other. Similarly, we have the rough support. So rough support is similar to the frictionless support. Here, the friction coefficient is infinite. So there is no sliding between two surfaces. And finally, the frictional support, where we can add the frictional coefficient, which will allow sliding between two surfaces after overcoming the friction. In this scenario, so there is this base to pin connection, then base to holder connection, and finally there is pin to holder connection. So the force is being transmitted from the holder to pin, and then from pin to the base. So these connections, they are detected correctly and automatically by ANSYS. So I'll just change these bonded contacts to no separation here. So like this. Next, moving on to mesh generation, we will see different mesh settings and see which one generates a good quality mesh here. If I move on with standard and default option with adaptive size control, I see that tetrahedral mesh elements are generated in majority of the assembly. So in this case, the best one that will work could be proximity and curvature, since there are multiple parts and there are holes as well. So we want to incorporate the details of the other bodies that are in contact with this setting. So if I update this mesh, we'll see that this is quite good based on proximity and curvature. So it takes into consideration both the surrounding bodies and also the curvature of the part itself. And we can further refine this using the relevance center here, and also using the localized control for each of the body. The next step is to add the fixed supports at the bottom of the base. So these three legs, they are fixed at the base, and finally a force is being applied at the top of the holder, and it is 1 kilonewton. So at this phase, the force is applied, the force vector will go in negative y direction. So this is minus 1000 Newton. And what I want to find is the maximum equivalent stress and safety factor. Based on that, this is the equivalent stress, and finally the deformation, total deformation in this body. After solving the base, we will see that we have the details for equivalent stress and total deformation. Here, the maximum equivalent stress is 77 megapascal, and the maximum value occurred somewhere inside here near the pin, and the minimum value is in the pin. And finally the total deformation, so this support, it actually moves down by 0.007 millimeter, and the safety factor, we can also find it there. So this is one way to solve the problem. We could have reduced this problem since this is a kind of a symmetric shape around this XY axis. If I look at, yeah, so I'll just go to the geometry again. And in the geometry, I can see that this whole body, whole assembly, this is symmetric about XY plane. So I can add a symmetry around the XY axis. So this is XY axis, which is passing exactly at the center of the assembly. For all bodies, generate, and the problem size is being reduced to 1/2. And if I go back to the model and update it again, update geometry from source. So here, along with the connections, we have the symmetry option as well. So this is much more better view, and we can visualize the result exactly at the face. So if I solve this, the equivalent stress you can see is 156 megapascal, which is very high here, and it's almost double as compared to the full model case that we have solved. And the maximum deformation is also occurring in the pin, and it is quite high. So the values, they are very different. It's because since we have used a symmetry condition, if I look at the boundary conditions here, the force applied is 1000 newton. So when applying the force on a particular face and using a symmetry condition, the forces, they are also half based on the model that we are using. So here in this case, the force will be 500 newton on half model. So if I were using 1/4 of a model, the force will be 250 newton. However, for the pressures, they remain same since they are being applied on the surfaces. So they are given per unit area. I'll just solve this again to view the results. After the solution, here we have the results. The maximum stress is occurring inside the pin. And if I run the solution, you see that the supports, so because of the linear no separation support, the pin, as the force is being applied, the pin is sliding in one direction slightly. So if I look at the total deformation, this is also similar. There is one more option that we can explore, and that is the beta option. So since we are using the symmetry for analysis, if you go to the tools options and under the appearance, turn on this beta options, check this, make sure that this box is checked, press OK and go back here on the symmetry. We can, for the sake of visualization, view the complete model even after solving a half model. So the beta options, uh, they provide us the liberty to view the complete model even after solving the half model. So here in the symmetry, I can use the graphical expansion option and I want to see the full result here. So I can repeat the result to 2 times, and the method that I'm going to use is half. So since this is the half model and this is about XY plane. So when I select XY plane and review the mesh, nothing happens. There is this distance that we need to specify. Let's add this to a very small distance, which is, let's say, minus 0.001 millimeter. And if I click on the mesh now, you will see a graphical extension. So this left portion that is created, ANSYS will not solve the matrix for this. So this is just a graphical expansion of the results. And without consuming any resources. We are viewing the full model here without reanalysis. So this is just a graphical expansion, and we can review the full model using this one. So this is how you can use the beta options for viewing the full geometry when you are using the symmetry option and model the assembly in ANSYS. Finally, this is the assignment for you, and you can use this assignment for the practice. Here we have four different components. There are two bars that are connected, and the force and pressure is being applied. To separate these two bars that are connected, and the contact is the bonded contact that is being used. So thank you so much for your time, and we will back with the next lab soon.